Was a um yeah, I know I just stopped streaming. I just had a quick shower and like fucking chilled on the bed for a bit. And I was like, hey, I'm kind of goaded at writing a lab report. Why not share how goaded I am at writing them? Because you maybe wondering, some people might be being like, might think like, oh, lab reports are so fucking hard, you know? You do lab shit. Well, this is a chem one, so it's one of the easiest, or a physics one. Chem ones are like hard as shit. But yeah. So, I always use a template to write my lab reports. Because templates are easy. You just copy and paste almost the exact same stuff, but, you know, change it for the situation. So, this is my own one. The lab we did was a collisions lab, super basic. You know, you should be able to do collisions. So always got a purpose statement. In your purpose statement, you write what exactly you did. So imagine you're describing the lab to somebody who has never like done physics before. You know, that's how you do it, and then either at the start or the end, you have to explain, why you did the lab. So for this is just a random example. Say you did a lab on like how fast, like, say you shot a bullet at something and you were calculating like the kinetic energy transfer between the bullet and what it hit. Say that that's your lab. Well, then the purpose statement, you would include like, in order to find the kinetic energy transferred between a gun and insert object, we did this, and then you explain everything about your procedure. That's your purpose statement. Observation slash analysis, you just put your data. It's always safe to add like descriptions of what it is, in case, like, say the person marking it or the person viewing your lab report, they question something you did. Well, everything's there, right? Like, you can't get mad at me. Yeah, so here's a couple of things. Of course, this isn't a very good one. Calculations. So when you do I didn't put any calculations yet because this lab, not really need any. But for your calculations, you should put like, here is some text describing the calculations below and what they are doing and why we are doing them. And then it's calculations. Next piece of text is same as first, but for next calculations. And then addendum, you keep doing that for every calculation. Of course, for me, like, calculations in this lab are like, there's not many. Graphs, again, you should always have a figure for your graph, like description of what it is. Always good to have. Here I got really lazy and I didn't want to like separate the graphs and write individual descriptions, so I just grouped them. Results you describe, you answer the question of the lab and how your data supports or does not support it. And the discussion is mainly about, like, you reiterate the purpose statement, you talk about what you found, and then at the end you say why it's important. That's your discussion. Yeah. So that's how you write a good, decent, I won't say good, a decent lab report. Of course, like chem ones, you're probably gonna have like 5 trillion more calculations and a lot more data, but physics labs are the easiest. Here you'll have your your cover letter, essentially. It's like a cover letter, but for a lab report, where it's like, you have, the name, the lab that you did, your name, like all the information about how you did it, blah 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 blah. Your university or your school or your fucking science advisor will probably tell you what you need to do. So yeah, that's what you do on this empty page. I'm hiding mine because it's all like personal info. But yeah, so I went for this nice blue and white aesthetic because I think it looks nice. You can just make yours, just black and white. You don't need to do all this shit. I also centered it. Makes it longer, but like longer to scroll through. Like if you look at a proper lab report, like prim and proper, they have it all sectioned out. It's, just landscape. But yeah. So yeah, that's how you write a decent lab report. I just started streaming because I was like, hey, I got time to kill and this is my lab report. So yeah. I'm probably just gonna like chat to myself like a nutcase about random shit because I am insane in the membrane and not in a good way, I must say. Speaking of being insane, oh my god, Hayabusa gloves are like, they are so expensive. They're like $89. And I was sitting there, I was looking at them, and I was like, brother, like, I want to see the animal get slaughtered in front of me and see them get turned into the gloves. Like, that is how I want. That's what I'm expecting. That's what I'm expecting with these prices, Like, what? It's like $89, almost $100 for Hayabusa gloves. It's crazy. It's absolutely crazy. Yeah. Anyways, yeah, I only have 3 things left to do on this thing. Or 2. 3, technically. Result. Which is... So the result for this lab, what they want us to answer is, like, is momentum conserved and is energy conserved? Shocking answer. It's not, because it's not a perfect system. But they want information to back it up. So you have to figure out, like, why it's not conserved, why it is conserved, blah, 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 blah. Yeah. I need to grab my phone, actually, because it has everything I need to finish this live report. I might play some, like, Super Auto Pets later, because it's good to take breaks when you do work, If you just do work, you'll be very tired and very depressed and sad and lonely and empty. Which is coincidentally what I am. And I haven't even done work yet. That's why I box. To get rid so I can feel alive. Nah. I'm just joshing. I completely lost my train of thought. I'm just gonna assume I wasn't talking about anything important, Yeah. Cool. So I just need to find if energy is conserved. Plus or 6, plus or minus the standard deviation. Okay. So the change in P, so I need to find the standard deviation of the change in momentum and the change in energy. Actually, I know what I can do on stream instead of doing these calculations is I can annotate my velocities, because this is not good looking. So instead, we're just gonna, so if you're on Windows, you can just do Alt, the plus symbol to put it into equation. So we're just going to do V subscript 1, which for some reason is, there we go. So we're going to copy and paste this and change it out for, there we go. Word is really finicky sometimes, but luckily it doesn't matter. Oh, for that one, we can just put V. We're going to put velocity. So, it might seem... Yeah, you could probably put V or velocity, doesn't matter. Depends on what they want you to do. So everywhere that this says V1, we're going to change to V. There we go. And then we'll do the same for this. Final velocity, we're going to leave that. Yep. And final V1, initial V1, final V1. Oh yes, because that's an inelastic collision. V2, so we can take this, put it here. Yeah, see, now it looks better. Also, I cut everything down to 3 significant figures due to the fact that if it's more, then the chart is going to go off screen. So you should always make sure it looks nice, you know? Like, it's not just about the information you put on. If it's hard to read and difficult, then you're not giving yourself any favors. Take the time and effort to make it look nice. It really helps. I think that's the reason why my goddamn finding the standard deviation of the change in momentum, and then hit them with the Alt plus sign, delta, and that's that, P. Oh, dear Afanged. How the hell? Oh. Oopsies. How the hell do we find standard deviation? Well, my little kittens. It's super simple. So we want the where is it? The omega sign? I ain't talking about male pregnancy. We were actually going to put a subscript of P there. So we want that. So then it will be the standard deviation that we get from our data. So some labs you might be using LoggerPro. LoggerPro is extremely finicky, but it's a good way to log data given the fact it's called LoggerPro. With all these things are taken with LoggerPro. LoggerPro can do a lot of calculations by itself. It really saves time. So that's where I'm going to be getting my standard deviation at the top. So we're going to take the standard deviation. So if I go back to my equation, which is insert, where is it? I'm just going to copy and paste it. So we're going to take this. Oh, it's white for some reason. There we go. But we're going to get rid of the P because I don't like the letter P. There we go. And we want that divided by the square root of the number of samples. So since we want to find if momentum is conserved, we'll probably want to do it for everything here, you know? Because these are PI, PF, you know, so this is P initial, P final, energy initial, energy final. So we're going to do that for, I think, every single one. We can just change the values and copy and paste. A lot of people, they'll do it manually. It kills a lot of time. Don't do it manually. You should never do things manually. Insert equation. There we go. So we want a radical of this. We want n to be in there. So we want to do this for each part of the experiment. change of momentum, delta P for each part of the experiment. This is going to be really tedious. It's only going to be 8 equations that I'm going to follow in quick succession. So I do need to crack open Logger Pro, so I'm not going to be able to see chat. Sorry. Or maybe you don't give a shit, which is very valid, because I don't give a shit. I should really stop swearing. It's a very bad habit I have, and a lot of people have, where you use swearing as a crutch of conversation. Because sometimes I feel that I'm very eloquent in my words, but other times I'm a Neanderthal who cannot go 3 seconds without saying a cuss. Anyways. Yeah, standard deviation, we have 0.01491. So again, copy and paste. Never not copy and paste. For some reason, this isn't centered. So we're going to take this, which is 0. That's what I said, 0.01491 divided by the square root of the number of samples. In this case, since it's the first one we did, 5 samples, so n is equal to 5. I think a lot of times, whenever people are given lab manuals, the people who write the lab manuals give really, really complex and stupid, convoluted ways of equations instead of just writing it out because they want you to understand why the equation's being used. But a lot of the time, you don't give a rat's ass. Is that a swear? I don't know. So, quickly do the calculation. 0.01491 divided by the square root of 5. Okay, cool. So that, we're gonna again use 3 significant figures, or in this case 4. That gives us a standard deviation of, so we can just delete all that, 0.006667. 0.06667. 8. So, the standard deviation for section I should section these. A, B, yeah, we'll do strong, you know. Strong. D. Strong. C. C, D. I almost forgot what came after C. Right. I hate it when it does that. Oh, whoopsie daisies. Where am I doing my calculations? I'm doing it in the result. Fun fact, Control X both copies and deletes what you've written, so it's very useful, so that you don't have to copy then delete. So the standard deviation for section A is, so now I need to go grab the delta P, which, damn. Great, now I need to find the average value. I think it should be on the logger profile. Mean 0.6, wait, what? Oh yeah, 0.6294. 0.6294 Or actually, we'll write this in an equation. 6294 plus or minus up on the insert equation bar, and then we take our value, put it there, and that is all in kilograms per meter. Kilograms, and then space, meters, meters per second. There we go. And now we can copy and paste all this. Do the exact same thing, but with different values. See, this is why lab reports suck. They are extremely tedious. Main reason why I hate doing them. They're just tedious for the sake of being tedious. Like, there's so many more efficient ways. There's actually not many more efficient ways to do lab reports. They're just so tedious. Okay. And for this one, since there's the energy of 2, if we go to section B, we have, what? Okay, so apparently I did my graph wrong. Did I? Energy initial, P final. Nope, I did it right. Are the values different? Yes, they are. Oh, it's the two different, ugh. Give me a sec. I'm gonna drink some water. I'm gonna put everything on pause for now. Sorry about that. I know, riveting, stream content here. I'm gonna keep it real with you. I just took a break. Yeah. Anywho, I was just looking at my graphs. I was like, damn. Why is there only one PI and PF? How does that make sense? I was looking at this. And when I say this, I mean my logger profile. If I hit grab options, is it different values or are they the same values? That one's the same. There should be one here, but there's not. Got this data point here. Okay, I'm very confused on this. So it's P initial minus P final. So that means it's 0.007 kilograms per meters per second lost over the course of yeah, it's that much lost over the course of it moving. That's what it is. There's only one PIPF for graph 2, so I'm gonna be honest, I'm not entirely sure why so if the standard deviation is the same, then that means that it's the same data points, or if everything's the same. It is. Everything's the same, therefore they are the exact same. Perfect. Which means I do not have to do individual calculations for both carts. I can instead do what I've been doing before and taking the standard deviation 0.04708. The mean of these ones, though, is significantly less. If I go to look at the PIPF is extremely small compared to here. Also, this one's a negative, so it makes it even smaller. Which is weird, actually, now that I think about it. Why is B here, 2 of them negative, 3 of them are negative? That means that the final is greater than the initial. That makes almost no sense. That means momentum is increased. Oh. Wait, this is 2 cards moving towards each other. You know what? It's fine. The data points are fine. You know? This is a completely A-okay experiment. Yeah, with experiments, it's okay to be wrong. It's more than okay to be wrong. How many? 1, 2, 3, 4 instead. Yeah, 4. Oh, the same thing twice. Don't need that. Don't need that. Yeah. It's okay if your calculations are wrong. You just need to be able to back it and be like, hey, this is why it's wrong. Or this is why it could have been wrong. 4708. Okay, and 0.0023554. So then we just take this value, plug it into this. We could put that into scientific notation if I wanted to, which I think I might actually have to do, given the fact that the mean is in scientific notation, due to the fact that there are negative values. Alright, so this is 735. Do this 1.735 times 10 to the power of negative 18, which is small, plus or minus 1, 2, 3, plus or minus 0.2. Oh wait, let's do this. 1, 2, 3. Times 10 to the power 3. There we go. This option beep. And we're going to do the same thing. Control C. V. Right. We whip out our third logger profile to find the standard deviation. See, this is what I mean by how lab reports are extremely tedious, because you're just doing the same thing over and over and over and over and over and over and over again. Okay, so for this one, did I not? No, I did do statistics for all of them. Sick. So standard deviation is 1, 2, 3, 4, 5. So 5 back to ROP in the 5 pack. 0.00 3597. Cool. So 0.00397 divided by the square root of 5 comes out to that number, which we will now put into scientific notation. 1769. 17.7. There we go. And the mean of that is 0.003880. 1, 2, 3. So also negative 3. It's better to write scientific notation. It makes you seem smarter, you know? 3.88. There we go. And over here we get 1.77. Plus or minus means 1.77 more or less than the value is the range. So if you have a bunch of things all over the place, then that means that your range is not means that your range is gonna be like pretty big in comparison to your data. Just a little tip, you know? In case you need it. You probably don't. If anything, you're probably laughing at the fact that this lab report is kind of dog water. I lied to you. This is not a decent lab report. This is a lab report that barely works. Why? Because why not? I say, why the hell not? Okay. So again, it's really annoying because you gotta keep doing this shit over and over and over again. And then I'm gonna have to do it again, but for energy. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Nope, 5. Oh, there's the 5th. Okay, so for this, hit him with this. Standard deviation, we're rocking a 0.007219. I was thinking, I feel like traditional celebrations of like holidays is slowly dying out. Hear me out. Maybe this is just me getting older, but I feel like since COVID, like traditional holidays have gotten kind of dull. Like trick-or-treating is not as big as it was. Christmas isn't as big as it was. Maybe that's just me getting older though. 3228. It could just be that. Which is honestly valid. Oh, wrong one. I am an old bitch. I'm not, but you know, I like to pretend. 2, 2. That's a nice mean. Is that right though? Probably, given the fact that it's run at 3 sig figs. Alright. For section A, section C, section D. Okay, got caps lock on. There we go. Nice. So that's that. Now I have to do the same for the whatchamacallit, the energy, because it's what God wants. I'll take a little break after doing those calculations. Maybe not. I'm probably just gonna keep going. Best part is I can do this. Sig. Change a little fella to E, capital E. Okay, back to this. Standard deviation 0.01146. Cool. I'll probably just do the calculations on my phone instead of whipping it up on the monitor, even though the monitor or the Google calculator is actually one of the best calculators out there. Don't need anything else. Alright, 0.0146 divided by the square root of 5. Which comes out to... That doesn't seem right. That's only slightly smaller, and yet the number is significantly bigger. Alright, 0.00. Oh, I put 0.0046 divided by square root of 5. Really? I'm gonna see if that's right. Because that doesn't seem right. I got a really small number, way smaller than the one I got before, so I'm not trusting it. Alright, so 0.01146 divided by the square. Oh, divided by the square root of 5. Nope, it's right. Damn. Oh, did I do this wrong then? Or is it just... Okay, well... Alright. 5125. I'm gonna redo my first calculation, because if that is that small, this shouldn't be that big. 0.01491 divided by the square root. Yeah, 0.00. There we go. Alright, this is going into scientific notation. Point there. There we go. Alright. 5.125 times 10 to the power of -3. And the change in energy, we rock in a mean of 0.02507. And these are in joules. Wrong letter. There we go. Joules. Sick. Copy, paste that. Work smarter, not harder. Hell yeah. Okay. We're done with that. So this one is 4 instead of 5. We're rocking, Jesus Christ, extremely small standard deviation of 0.0006941. 3 zeros. Divided by the square root of 4. Which comes out to 3205. So that's 10 to the power of 1, 2, 3, 4, 4. So 3. Sheesh. Oh, oopsie daisies. That's supposed to be the answer. In reality, it's 6941. There we go. We rock one of those, and then our mean for the change in energy is 0.002836. Which we can then write as 2.386 times 10 to the power of -3. 1, 2, 3. Yeah, cool. Fucking pog as shit. If anything, we should take this one and put them all here, because it's more likely that we're going to run into extremely small numbers in our next couple of changes in energy. So we're just gonna do that. Yeah, we are. So this is for section C. Is energy saved? And for most of them, no. It's not. Energy is not saved. There's always going to be a loss of energy or momentum due to the fact that there's friction between the cart and the ground. Like, that's the reason why energy. Momentum's lost due to air drag and that sort of thing. Like, no matter what, there's always going to be a loss, no matter how minute. Question is, do you give a shit? Alright, standard deviation here is 0.01359. Okay, let's do the calculations. 0.00135 divided by the square root of 5. Coming out to a good old fashioned 0.006078. Locking one of those with a standard deviation. So the mean is 0.01014. Now that's the mean of the. Oh, and also it's only 10 to the power of 2. This is still the same. 6.078. There we go. And now for the last one. The best one. My beloved section. What is it called? My 4th Logger Pro is what I'm just gonna say. And if thou letteth me cook. What the fuck? Give me this. Standard deviation. Okay. Alright. 0.007019. Again, let's do the calculations. 0.007019. Yep. Divided by the square root of 5. 0.003139. And we have a mean of 1.31. 1.31. Over here, 3139. There we go. So, so in the result we have to do, because the conservation of moment, okay, I'm happy with what I'm doing. I'm gonna finish the result right after I take a tiny break of drinking some water, and then we'll play some like battle packs or something, just a quick easy game. So be right back. Alright, I'm back. So conservation of momentum is not conserved due to the, oh god, I gotta use delta P. I'm just gonna copy and paste it from before. I don't feel like using an equation. Delta P for all the different collision types being positive, because the equation used to find the change in momentum has initial minus final, so then that means it goes down. Subtracted by the final, meaning that the found number is the amount lost in movement. The same is said for the change in energy. Energy is not conserved over the course of all the collision tests, as for the same reason as momentum is found to not be conserved. Yeah, because we're fine. Is momentum conserved? Is energy conserved? Doesn't say how much. It should be conserved. We found everything. We did everything. Or I did everything. Or we. You know what? It's a team effort. Alright, and the discussion. This is one from a previous, so... discussion is revamp previous. After conducting all of the different types of collisions shows that the momentum and energy is not conserved. Reasons for this is that the friction between the cart and the rail system reason for the energy not being conserved over collisions. Cart and the rail system turns the kinetic energy of the collisions into thermal. A reason for why the momentum is not conserved is again the friction between the wheels and the rail system slowing the car down, as well as possible air resistance due to the shape of the carts. While these values are not big, they still show a non-conservation conservation of energy and use of. I'm just gonna use the calculations due to it makes it look better. Joules lost does not look is not large, but it still shows energy being lost. Same is said with value. J found for section A. Alright, so we're going to save this right now. I'm going to crack open a previous document due to the fact that I just want to make sure that my file is good. Because I have quite the banger. Alright, it is important what is what? Why is the whole page getting deleted? Let's save. Is important. Okay. It is important to realize that no matter how perfect an experiment seems to be, there will always... Also, another tip for writing, don't use past tense. I always make sure to not do that. I don't know why, but I think I vaguely remember one of my professors saying that do not use past tense. But hey, I just make sure, and it also just helps the creative juices flow, you know? Gets the brain moving. If the fucking sorry, I swore again, but if the assignment doesn't do that anyways. These be some factors that you cannot completely exterminate from an experiment. Alongside this, knowing how collisions work is essential for pursuing a deeper understanding of physics, as at the molecular level collisions are happening every second, and collisions are integral to many working fields. Architecture and understand the forces of colliding with a bridge, and what else? Sports. I don't know what else. Bridge, for example. Okay, I think this is good. Yeah, I think this is good. This is not one of my best ones, but it's pretty good. Yeah. I hope you guys like my background. I just took it off of Squatic Skeleton, because skeletons are fucking hard. Especially, again, I swore for no reason. But skeletons are hard, doesn't matter what. I saw it on a meme where it's like, my body turns insert thing to thing. My body turns yaoi into gains. My body turns Yuri into fruitful conversations with people. Yeah, because it's hard. It's a hard image. Date submitted. It is the 11th month, 16th day. There we go. I think I'm done. Yeah. File, save as. Documents. Browse. Documents. Scroll in uni files. PDF. Collisions. Save. Go here. Go here. Go here. Here. Upload. Show all files. Documents. Scroll down. Open. Upload. Submit. Yippee! I did it. Nice. Okay, so assignment 8 do. Okay, cool. Nice. So yeah, I'm probably gonna go to sleep, and tomorrow I'll probably do another like working stream. Probably more interesting than this, because I can actually show the process of finding research topics and annotating work. I'll also play Lunacid, so tune in for that. Yeah, that's how you write a lab report. Wrapped it up today. And yeah. Hope that you had fun watching. Mr. Zero Viewer. Ho 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 ho. But yeah. I'm also going to clutch up with watching one on Friday. I actually am going to an amateur boxing event on Saturday, which is pretty hype. Get to see my competition, you know? But yeah. Ciao.